Alright, another draw physics video presentation. Alright, first I'll do a little comment. A little one. Piro is such an idiot. Delusions exist. Yeah, he's just... I've told you for years you don't need a silvered mirror. Regular glass crystal reflects some light and lets some light through. Now, I played the Feynman video on the layers of glass at least 5 years ago. I've been talking about how beam splitters work for years in terms of the fact that the glass is a problem, and the fact that the silver on the glass, creates little slits and all that kind of crap. So I've been through this. I showed that you can make the pattern of the interferometer, that is the round bullseye pattern, by just putting dirt on a piece of glass. Right? I mean, I did that experiment on my porch 2 or 3 years ago. See, he obviously doesn't watch very many of the videos, right? I mean, that's what any of you regular viewers would concede. He must not have watched too many of my videos to think I don't know that glass reflects a percentage of the light depending on the thickness of the glass, that you can actually polish the glass and change the reflective index. Newton did that. It's one of those Newton things. I mean, it's just so freaking stupid. He doesn't have any video explaining how light reflects off glass. It's completely made up in his head. He's never made such a video, never made such statements. It's just amazingly stupid. So anyway, and this is on the video on the interferometer, which is really talking about the fact that you have internal reflections. That's what thin layers do. They create internal reflections, and that is what's creating the pattern. But anyway, the surface of water reflects some light and lets some light through. Do you think water surface is silvered? I mean, it's so insulting, this patronizing, silly, stupid question. Do I think up is uppy? I mean, what the fuck is this stupid question? I mean, it's, just points out that he obviously hasn't watched 10%, 5%, 2%, 1% of the videos. Because there's no way he could have missed those conversations about reflections off of glass, because I've talked about it so many times. And top layer versus bottom layer, phase shifts, all of that crap. And, just to ask a question is stupid. And in this context, like LIGO is somehow going to use a bucket of water to reflect the light. And the key point is what's the beam splitter made of? I've heard LIGO talk about half silvered as being a beam splitter, so maybe they've changed that to some sort of thin film beam splitter because their laser has gotten so intense that it'll melt everything else. But I haven't heard anything like that. So I guess we'll have to research that one to see what their beam splitter is made out of. And anyway, my argument is no beam splitter creates equal beams, and this whole thing is just a pile of crap. It's based on theoretically impossible events. So anyway, I say to him, how do 36 layers reflect light from a location in the layers that is the exact enough to see 1/10,000th of the width of a proton? It's obviously, even if both beams are being varied, they're both being varied. And the fact is every time a photon goes through, it's going to go a certain different average distance, a different distance. You won't be able to make it all the same each time, each event. And so your ruler can't be dependent on. And so how can you, with a ruler that's not dependable, measure such a small distance? It doesn't make any sense. Yes, I know glass reflects light. The fact debunks beam splitters, that fact. And you could just argue that the idea of a beam splitter splitting the photon evenly is kind of a nonsense, because piece of the photon goes off the top layer of the glass, a piece goes off the bottom layer of the glass, which is really thick, and then another piece goes off the silver. Obviously, that composite could be any kind of average in terms of distance inside the glass, and those distances are huge compared to over time compared to the width of a proton, certainly. but they're still big compared to the width of an atom. So you can't even measure the thickness of an atom, let alone a proton, with such a device. So anyway, just crap. That's all you can say, really. That's all I can say is, God, this is just crap. Some asshole went on about Ken Wheeler's bullshit, and it's just so irritating. These people don't really pay attention. Let me do this comment just so I can delete it. Do you know that what the dielectric is? A dielectric is a substance, for frig's sake. Okay, there's nothing else about it. It's a substance that can, okay, influence a charge field, an electric field, if you want to call it that. The electric field, so now the electric field, okay, is composed of the magnetic and the dielectric field. So now, does that make any sense to anybody? The electric field is magnetic and dielectric. It's not electric. What does that even mean? Oh yeah, that's right. It doesn't mean a damn thing. It's a charge field. All electricity and magnetism are charge. Okay, that's what's causing them. This was discovered by Michael Faraday in the 1800s. Yeah, Michael Faraday also discovered the gear turning, reality. Lots of antique scientists had kind of notions that weren't too good, because they didn't have all the facts we have, and that's just the truth. And so you want to go back to the primitives and ask them what reality is. You're going to find out that reality is God and a lot of mumbo jumbo. All right, you can read more about it in the dielectric, about the dielectric in the books, Dynamic Theory of Electron. Okay, Maxwell's book, Waves and Impulses, and others, Steinmetz. These are all archaic creatures, right? I mean, heavy side. So you think that physics was real physics, and the modern physics, where they've actually done a lot more dissection and know what these creatures are made out of a lot better. I mean, there's a lot wrong with modern science, but frankly, you can't deny that technology has allowed us to see more than we saw in the past. This is the true electromagnetic theory. Well, whatever. Says you. You're going to go back to, how far back do you want to go? You want to go all the way back to Prodicus? Anyway, all human progress is built on ether theory. Prove it, moron. All human progress is built on ether theory. All the breakthroughs of maternity are nothing more than the innovations in the technology developed by ether theorists. Well, it's just not true. So you can say it, but it's not the truth. It's nowhere even close to the truth. It's just a delusion you have, where you've made up some huge innovation. Again, Tesla's motors aren't even used in most motor cases. Okay, he didn't invent AC current. All that is complete nonsense. And would not function at all without relying on technology developed by ether theorists. That's just absolute nonsense. The technology of the spinning motor was developed by a lot of different people in pieces. And yeah, Faraday put it together and showed it actually working, but actually doing something. But he didn't do it because he had an ether theory retard. I mean, that's clear from his own notes. It's nothing about the ether. He wasn't saying, look at the motor stirring the ether. No, he just said, look, you can put a conductor with a current going through it in the proximity of a magnet, and you'll get this effect. So, you're just religious kooks. All right. I'm so sick of these douchebags. Anyway. Alright, so that's it. There's no other comments relevant to the videos, nothing. I mean, there's just nothing, which is fine for the idiots to say nothing. That's the way it should be. But yeah, all these protesters, well, why don't you sit there and prove that I'm wrong about something? So why don't you take one of the videos in the subject videos, and especially the most recent video on the double slit experiment, where I do debunk it and demonstrate how the little trick is done, and demonstrate where I'm wrong, where I made a mistake somewhere of any critical or important substance. I don't know why they filmed this video in old TV mode, but anyway, it was 2008. So anyway, So we're going to play some more of this World Science Fair bullshit festival, whatever, Brian Greene horse shit. Because it's just so bad and just so illustrates this is just religious talk, fun religion.
So I just want to end this presentation by noting the following thing. The scientists who came up with these ideas struggled valiantly to try to reconcile their intuition about the world.
Okay, so they say they struggled valiantly. I would argue they really didn't. Okay, they really dismissed things really, for casual reasons, like mock gravity. It works so well. It's so perfect in explaining. It's so connected to what lights do and all these other things. It so makes the inverse square law make a huge amount of sense. And yet, because of this momentum problem of drag, not thinking that one through at all, they threw that out and they didn't think about it. And they just gave up on all notions of real quantization of momentum and gave up on it. And they also just didn't think of it because, works out that way. Those key individuals didn't think of it. Because the key individuals didn't think of it, it didn't get talked about.
Intuition that's built up from everyday experiences where things seem so definite.
Yeah, well, they seem pretty definite. That's right. Everything seems to have a shape and everything seems to have a position. There seems to be this whole conservation thing. You can't have up without down. You can't, equal opposite reactions seem to be all over the place. All of those laws seem pretty secure, and they really don't work in your magic verse where space is poofing particles and, it's just, you're the ones threatening all of that and saying somehow it's not true when it seems all the evidence indicates it's true, and only your misinterpretation of complex phenomenon, that's the only time it gets a little dicey, is your interpretations.
Things seem so manifestly here or there without probability. They tried valiantly to reconcile their intuition.
Okay, well, we know that's true. I mean, we know I can flip something, and I can do it every single time. It'll come out the same result. I can flip a penny, just one little tiny flip, get it to go heads, and I can do it. If I practice, I can do it every single time. No probabilities involved. Just real hard physical facts.
With what was emerging from the experiments and the theorizing, and just to give you a sense of the struggles that these...
Okay, so this is a sense of their struggles, but no, it's just a sense of their, oh gee, this sounds like we're getting into an awful mushy ground of, religious hokey pokey, and they didn't like it. But it didn't indicate that they really had a way of thinking about it that was going to fix it. They haven't, they just didn't think of the catch. I mean, the catch is this simple idea of 2 + 2 + 2 physics, where you just say there's two kinds of force and there's two kinds of charged particles. They work inversely to the forces in the sense they have two opposite reactions to the two opposite forces. There, you're done. That can resolve the mystery.
Individuals went through. Werner Heisenberg, who won the Nobel Prize in 1932, said, I remember discussions with Bohr, which went till very late at night and ended almost in despair. And when at the end of the discussion I went alone for a walk in a neighboring park,
So again, this is kind of ironic just because Heisenberg came up with the woo principle of, somehow particles don't know where they are. If you're looking at them, you're trying to confine them. They resist confinement by behaving more erratically. Bullshit.
Repeated to myself again and again, can nature possibly be as absurd as it seemed to us in these experiments?
So again, these experiments are simple things like the double slit, where, they just never could break free of their wave mechanics nonsense. And if they did that, then they could understand that, photons are more complex than we thought. They're composite objects. Einstein, 2 years before he died, said, I've been studying photons for 50 years and I have not improved my understanding one iota, indicating that he saw a real problem in the fact that they really don't have a good diagram of this object.
Another Nobel Prize winner, who won the prize in 1914, Max von Laue, he said, if it turns out to be true, I'll quit physics. And finally, the master himself, Albert Einstein, later in his life, he said, I still believe in the possibility of a model of reality which represents things themselves and not merely the probability of their occurrence. And we'll talk.
Right. So he's saying that they have a reality, that they're not being dictated by a probability. The probability is an outcome of their interactions with the world. And the whole point is that it's so obvious by the fact that the only time you see these phenomenon is when you force photons to interact with matter. You don't see it when photons are freely flying through space. They don't do any of this crap. All right, there's no confusion. So this is being caused by real sides to the dice table and the floor and the physical mechanism. They're arguing that somehow the dice really do just turn spontaneously in space and change what face is going to land. They're saying there's no physical reality that's causing the effect.
Talk about this.
Physical variables. I mean, it is a bold assertion they're making. It's, you know, it is in the same kind of realm of UFOs and gods. And yet they're not required to produce anything like extraordinary evidence for these claims.
Idea a little bit later on, but what we seem to have found from
what we seem to have found and completely have decided it's the truth, and we really haven't accepted any examination of whether our truth makes any sense or not. We just say things and we invent things like dark matter and all the rest of this crap that are just obviously desperate efforts to fix a theory that doesn't work.
Experiments and from theorizing is that there is an unavoidable element of chance in the way the world changes from moment to moment. There is an unavoidable element of probability.
Okay, so again, we're talking about all the experiments are interaction experiments. So there are variables. They're saying that variables aren't causing the effect. The slits don't have any, the surfaces don't have anything to do with what the photon is doing. The photon isn't being fucked up by surfaces. No, it's being fucked up by some magic god that's fucking it up. That's their assertion. Understand it, you know, appreciate the depth of this woo. Okay, if you're going to defend this woo.
In the laws of physics, the universe evolves in some very real sense according to a throw of the dice.
And so they do this crap. I mean, I shouldn't play it, but I mean, it's just so freaking... I mean, I would be so... This is scientist, you know. This is so embarrassing. Besides being gay and all that other crap. I mean, you're just sitting here saying this. It couldn't get any worse. They're talking babble. It couldn't get worse. This is like having a, you know, the Jesus pageant. You know. Oh, no, you know. Why don't they do that one next? The Moses pageant, you know. Sasquatch pageant. La 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 la. You know, pantomime physics. The little random, I mean, what's the difference? Elves, gnomes, you know, demons. What's the difference? Right? They're basically saying that some kind of silly little thing bouncing around in the universe, little homunculuses, are fucking with it. And you're buying it. Shit. The dice isn't even a... doesn't even have anything decent on it. They couldn't draw a decent picture on the fucking dice. Oh, yeah, the little demons got tired. Oh yes, applaud that shit. I mean, wasn't that a pile of shit? Yes, wasn't it a pile of shit? Yeah, sorry, yes, I'm allergically reacting to this physics. Oh.
So from Groucho Marx to Niels Bohr, it's hard to get. Pretty much all of us think so.
So Alan Alda, Mr. Quippy, Shit.
But for the next hour, we're going to be talking to some experts who
He's dead by now, right?
do get it to a great extent, I assume. And we'd like to hear a little bit about what you get, and maybe you can inject us with it, infect us with your getting of it. We'll be talking with Max Tegmark, who is a renowned cosmologist, and in his spare time is a proponent of the many worlds interpretation.
Yeah, it's complete, absolute baby bullshit. Let's just make up new universes for everything and everything that we understood. So you roll the dice, and a new universe is created for each kind of, action. So you can have a new universe, and it's all got boxcars. A million of those. And then you have a million universes that have snake eyes. And then a million universes that have 7. And the implications of that going forward. All those universes stay intact, and they all make new universes, and it just goes on and on and on until you get to whatever, 10 to the 458th power or something. And that somehow makes sense.
Of quantum mechanics. And that says that if quantum mechanics says there's more than one outcome of any action, then it will happen in worlds other than the one we're aware of. Do I have that roughly right?
In this universe, you have it right.
You can't count the ones in which I have it wrong. And Bill Phillips is a quantum physicist who you could say is working in the trenches. He manipulates atoms so that they can be used for different applications, like atomic clocks. And in 1997, he won the Nobel Prize for his work. David Albert is a philosopher. David Albert is a philosopher who was also a physicist himself, and he is renowned for his insights into the thorny philosophical questions raised by quantum mechanics.
Oh, bullshit on that. He's a douche. A well-decorated douche.
And Brian Greene, as you know, works on string theory, and it's
absolute nonsense. Little happy strings that float around in donut shapes or straight lines. And
effort to bring quantum mechanics and gravity together, something I've always longed for myself. So here's the thing. I'm just wondering why it's so hard for us. Maybe it's hard for us because we've evolved in such a way that we're adapted.
No, they hide everything in some sort of bullshit about some forky thing that, we have the Schrodinger equation, which basically means we find out everything about something and then we describe it and call it a great prediction. So I find out that the thing is blue or green, and blue, I guess that is. And it's round, and electricity comes out of it, and it's got lithium in it. And I find out all these details, and then I predict it's a battery. Woo! And because I hide that in this notion that somehow this formula told me all that stuff, when the formula didn't tell you any of that stuff. You had to observe that stuff and then put it in the formula. The formula didn't do anything. It's just such horseshit. So they pretend that all these little symbols and all this bullshit is actually doing something when it's not doing any of the work.
Seeing the world only the way that's useful to us, at least up until now. We don't see the billions of...
See, they can't predict, like Newton's glass experiment, where you polish the glass and the reflective index changes. They don't have a formula that predicts that's going to happen until they see that it happens. And they know it's a consistent change. See, if the change was inconsistent, like you polish the glass and it goes from 7% and then it goes to 16%, and then it jumps to 2%, and then it jumps to some other, then their formula wouldn't work. Because the only thing it can work on are changes that happen in a cycle. It goes 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and they're all in the right order. That's the only way this thing works at all. Is they have to find a phenomenon that has a pattern. And if it doesn't have a pattern, well, then they're lost as everybody else.
Of microbes on our arms. I mean, there are a lot of parts of our reality that's invisible to us. It might have an effect on us. We might get sick from them, but we don't see them except with instrumentation. We don't see, except lately in the last century or so, we don't see outside of the range of light that we're adapted to. And it affects us. We're affected by ultraviolet rays and that kind of thing. But we don't pay attention to it most of the time. Is it possible that the quantum world exists and may, not only...
Yeah, I know, but we do exist in a world where we know that all these forces have the same speed. And that should be a clue that they can't be as diversely created as bent space and then some quantum magic. You can't have two explanations. It's too obvious that whatever the stuff is, the whatever's happening on the small level, it's happening because of an instrument that is the same instrument, something moving the speed of light, the speed of force. That is so glaringly obvious.
Effective, but we are it, but we're not adapted to paying attention to it. Maybe it's with your machines and your theories, you can see it, and we can't, and we somehow need to bridge that gap. I mean, just take this first thing. Brian was showing us on the screen the two-slit experiment with the waves. So
with the waves, right. And if he did the two-slit experiment with the waves, it doesn't work. It doesn't create the right pattern in light. So why don't they deal with that huge glaring fact that's sitting there, right there, glaring right at them? Two waves will not create that complex pattern. It's just a fact. Not enough happening. Not enough variable change. Not enough there. And the only way it works is if you say, no, it's the four surface experiment. There are four contributions from the four surfaces. And they're the things that are creating what is a photon and what isn't a photon. I mean, that is glaringly obvious. And they just ignore the facts because the facts don't indicate they're right. The facts indicate they're wrong, and they'll never talk about it.
Whole idea of a probability wave. You know, when these electrons are fired, they're single electrons, right? And they're fired. So let me ask Max, you're the expert close.
Now, see, now this is the dangerous experiment, right? Because they're not single electrons. They're X-rays pushing electrons. So it's their whole understanding of what makes an electron move. They think electrons have perpetual motion. That is, you get one moving and it'll keep moving forever. There's absolutely no evidence that's what electrons do. There's every bit of evidence that electrons will slow down and crash into something. That's what we see in the cloud chamber. That's what we see in the world. You can't shoot electrons any kind of distance without them running out of momentum. So why do they think these electrons are all by themselves? Even when you have an electron gun and you're shooting many electrons, they know, okay, that's why they put shielding up. You know, they put shielding to prevent them from being irradiated by X-rays and cosmic rays that the device they're shooting the electron is producing. It's a beam of light that's pushing the electrons effectively. There's light pushing the electrons. It isn't that the electrons are just shot all by themselves and there's no other radiation in the experiment. That is obviously not true. They know that, so why don't they say that? But they give people the impression that you can shoot electrons like you're just shooting bullets, and that they're not explaining that, oh yeah, well, what's going with the bullets is a whole bunch of these little bullets. Okay, so it's not just the bullet that's going to hit you. I'm going to hit you with a bunch of gunpowder that's going to keep going just as fast as the bullets, or faster.
Just his hand to me right this minute. We think of that now as a probability wave. Is that a real thing, or is that a mathematical construct?
So they don't even agree. So this is one of the funny things, right? Because you put physicists in a room and they won't even agree on this truth. And so isn't that glaring right to you, saying they don't really have any hard evidence, that they shouldn't really be talking about this at all because they don't have any consensus? It is so unclear that they can't even agree on it?
Well, the most important thing you're going to learn tonight is that even today, a century after this theory was first pioneered, you get experts on stage who will disagree passionately about the answer. I'm chosen to be.
So right, and that makes sense. It makes sense for you to propose a theory and call people science deniers if they don't accept it, when you can't even agree on it. So you won't call each other science deniers, right? You won't call the people the same names you'll call somebody else who doesn't accept your quantum woo bullshit. And here you are proving that it's woo because you can't even put a collection of facts together to convince other people who are supposed to be informed on the subject. How did they miss it if it's so fucking proven?
The fall guy here, I think, the minority who thinks that the probability is just an illusion. And let me explain why. I think that what seems to us is random is really not random, and it has to do with cloning. So let's forget for a moment all about quantum physics. And let's sedate you. You go to sleep, and while you're sleeping, I'm going to use some nanotechnology.
But I think some people in the audience are already there.
That guy in the back. And
You're going to sedate me.
I'm going to measure where every atom in your body is and build a perfect copy. So we're going to have 2 Allens, and then I'm going to wake one of you up right here on stage, and the other Allen is going to wake up in Washington Square Park. Okay? And both of them are going to have exactly the same memories of this discussion, this sedation, right? So if I ask you now, which of those 2 Allens are you going to be? If I ask you specifically, where are you going to wake up?
Well, you just answered the question. You made 2 different people. They're both going to wake up and experience it as if they are the same person. One of them is not going to be more Alan than the other. So that would be silly to think. So obviously, they're both Alan.
You can't, it's going to seem, the one Allen is going to feel he randomly woke up in Washington Square Park. The other one is going to feel he randomly woke up here. There's no way for you now to predict where you're going to wake up because both copies are going to wake up somewhere, right? And the parallel universe
Well, I would predict that, yes, I'm going to wake up in both places, and both individuals are individuals, and both individuals will now have a different life history, and they will experience different things and become different people.
Of quantum physics, which we're going to argue about, it says exactly that. That's what's happening. You were effectively being cloned. The little particle.
So he didn't get to the real question about whether or not the functions, these different creations of Allens, is a real thing that happens, like real different copies are being made, or whether it's just a synthetic idea, okay, that there was 2 different Allens, and then we measured Allen 10 years later and said this Allen is this kind of Allen because he took a certain path. He woke up in that park, or he didn't wake up in that park. So he never got to the real question, was which causing the variable. Is the variable because the universe has some variable making device inside of it, a god or whatever, gremlins, that force things to be in a different place? Or is there real physical structure to the universe and things have to have a real physical interaction? And there really was only one copy. There was just imperceptibly different ways that one copy could have traveled. And because we can't perceive the different paths, because we can't see all the roads that lead to Rome, we can't say for sure which road the guy traveled to get to Rome. But he traveled a road. Now, I mean, the question is can you get to Rome without traveling a road?
Not just the little particles they were made of that can be in 2 places at once. Brian very nicely showed how an electron can go through 2 slits at the same time.
So again, that's their statement, right? Maybe they all agree that that's what it does. That an electron splits into 2 clones and goes through both slits and has 2 different interactions and blah, 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 blah. But shouldn't somebody question that whole perception? Do you really have any evidence that that really happened? And again, the argument is if you apply it to photons and you look at the photon pattern, it doesn't justify that conclusion because 2 electrons going through the slits won't create the pattern. You need 4 electrons.
Since we are made of these particles, we too can be in multiple places at the same time, and you can be here and in the park at the same time.
Okay, well, let me ask you a question before other people rush over and choke you.
Go for it.
When you say that you can that these particles that the wave the wave problem, the wave function is not a real thing. Are you saying that these particles are splitting off and going into other worlds or not? I mean, they're coming out of this electron gun and they're going through 2 slits. So what's happening? I mean, it didn't sound like you explained what was happening.
So
right, you didn't explain how you got these magical variables. So we're just talking about this variation that doesn't have a cause. So we're talking about the uncaused variation. Is there an uncaused variation? And do you have any real evidence that there's an uncaused variation? That is an unphysically caused variation. The variation is being accepted. The existence of the variation exists. The question is, I would argue it's scatter. I would argue it's a physical consequence of a physical interaction that we can't see, but that does have variation in it. There's not a magical variation force. So why don't you just say, no, you believe in a magical variation force?
Not like you went into this other thing.
So the one thing we all agree about is how we should calculate the math. And the math just says there's this curve, which Brian showed nice plots of.
So again, this is the nonsense part, right? Because the math doesn't do any of the work. The math doesn't tell you what the pattern is until you put the pattern into the math. You actually have to put the details of the variables into the math. And obviously you can leave it quite incomplete, right? I mean, I could say, I know all the paved roads to Rome, And so I can assume, okay, I'll put those in the variable because most people take the paved roads, but there's lots of dirt roads and lots of other variables that somebody could have come that way, and 10% could be coming that way. So I haven't accounted for all the variables, so my prediction is just a generalization. And that generalization can have an awful lot of imprecision.
Brian called it a probability wave. That's where it gets contentious. Whether you interpret it as a probability or something else, usually so we don't fight so much, we have a different name for it. We call it the wave function.
Okay.
It's a curve.
Okay, so in other words, you're saying that it's not a probability.
It's just a mathematical thing. We all agree how to calculate it. And then Brian showed a beautiful animation of how this can spread out for little things, and he said that for big things, it doesn't spread out. But the problem is that Erwin Schrödinger pointed out that you can actually devise experiments where even this wave function for big things also spreads out. He pointed out that if you take a cat, and then you build a horrible little device which kills it.
So this is so silly, right? I mean, because Schrödinger was making this argument against Heisenberg and Bohr, against this Wu theory. So, this is where they just completely pervert the history. Like, Schrödinger came up with a thought experiment that demonstrates that cats can be dead and alive. No, he was saying it's ludicrous to think cats are dead and alive. He's pointing out how that's so silly. And here they are converting it into Schrödinger proposed, when no, he proposed it's ludicrous. He didn't propose it makes sense. Oh, shit.
Cat or not, depending on what just one atom does, then afterwards the whole cat is going to have very spread out one of these curves and be doing two very different things. So it turns out we can't confine this quantum weirdness to the micro world of the small. It spills out and causes all this wonderful confusion.
Well, as I said, they would explain it all to you.
So that was a pile of horseshit, right? I mean, it's not unfair for somebody to just say, well, that was real babble, wasn't it? Wasn't too much science in that shit.
What's your take on this?
Well, my take is very different from Max's. Max has a very interesting but not entirely orthodox view about this, and I fall into the more conventional and orthodox point of view, the same one that Niels Bohr took. And
the religious kook, frankly. Okay, so God does play good dice with the universe.
And so to understand what my take is on this, let me just...
Quit telling God what to do. I think that was Bohr's statement to Einstein. Quit telling God what to do.
Back up a little bit and talk about this two-slit experiment again, because it's a wonderful experiment. So you shoot an electron at these two slits.
So shoot photons, please. The most famous experiment is photons. The most practically done experiment is photons. Why are you converting into electrons, which are incredibly difficult to do this experiment in any kind of rational way? They're charged objects. You can't shoot them at anything without the charge of the thing you're shooting them at affecting them. How can you even think about shooting an electron through two slits? What charge are the slits going to be? What are the electrons on the surface of the slits doing? How can you possibly say that you have any expectation that electrons go right through a slit when they're charged? I mean, it's completely different. You can't do it with any kind of at-home process. There's not a simple experiment. So why don't they talk about photons? Oh, that's right, because then, to be honest, they'd have to show the right pattern, and then they have to explain how two waves ain't going to make that. Two wave functions don't make that pattern.
And what quantum mechanics tells us is there's no way that we can tell where that electron is going to end up. But it's going to end up someplace. All
right, so let's understand that that's a fact, right? That's an observable fact that electrons don't travel very straight, okay? That they can travel quite irregularly. And that's a function of the fact that they're charged, that constantly they're doing this as they're doing this. Now, this can have an average and not mean that it goes in any direction. It means it goes as much this way as it goes this way, so it just kind of balances out and averages out. So it can look like it ends up in a straight line, but it never traveled a straight line.
When it hits the screen, it's going to make a flash of light, and we can tell where it is. But beforehand, there's no way of telling. If you shoot a gun, you can tell where the bullet's going to hit. But if you shoot an electron, you can't. Now, the problem is...
Right. But that irregularity is... The problem is are you saying that irregularity has something to do with a magical electron capacity to go someplace other than what the physical environment tells it to go? So again, is it the variables in the physical reality, or the variables in some sort of magic space? And I don't think there's any good reason for anybody who's a seriously sensible person to say, I jump to the wacky conclusion instead of jumping to the, oh, there's a variable that we just don't see. We haven't figured out why electrons are flying funny.
how to make sense of that if that electron is really a real object. And the way Max likes to make sense of it is that in one universe it goes there, and in another universe it goes there, and in another universe it goes someplace else. And the way Niels Bohr makes sense of it is to say you're not allowed to ask that kind of question.
All right, so now is that anything close to scientific? Of course not. I mean, that's just such an evasion.
That's the orthodox point of view in quantum mechanics.
Right, so that's their orthodox. Stop thinking and just calculate. And calculate based on what? Calculate based on you know what the outcome is. Just accept it. Don't try to figure out why it's what the outcome is. It's just so bad. They don't predict anything. Again, they don't predict a single thing until they know everything about that thing. It's just nonsense to say they have some formula that predicts everything. It predicts nothing.
Such a question is meaningless. The only thing that's meaningful is what is the result of the measurement. And so you can calculate what the probability distribution is.
And you calculate the distribution by observation. So again, this is just such a lie to say they have some calculation that told them ahead of time, you know, how muons are going to behave or how electrons are, how this or how that. No, not until they know something about the physical structure, not until they already know some of the functions. And it'll be some of them. And that's the flaw of their mathematics, is that they're gross generalizations.
We all agree on how to calculate. What we don't agree on is how to make sense of that, how to interpret the calculation, how to say, what does that calculation mean? So Max says the calculation means...
So it's back to Newton and the glass, right? So you're just saying that you know that when you polish, when you take a layer off the glass, you polish it, you rub it. That, or you can add glass, you know, but we really don't have a way to add glass conveniently. That you change how much light reflects. Now, you know that it's got to be some kind of mechanism that's causing the effect, right? There's a physical fact. You're changing the thickness of the glass. That changes how much light reflects off the glass. And you know it goes through a cycle. You know, from 0 to 16% of the light will reflect. And why would I think that this isn't something being caused by a physical circumstance? Why would I think that the glass somehow has knowledge of how thick it is and says, I'm this thick, I am going to change my reflective index? You know, the reflective index has something to do with your changing the atoms. Somehow the atoms are changing, and that change in what the atoms are doing will change how the photon reacts when it hits the atoms. What's so complicated, right? But they don't have a formula predicted that if you rub the surface of glass, you change the reflective index. There was no formula that predicted it.
That there's this distribution of all these gazillion different worlds in which the different things happen. And my interpretation is, in the end, I measure something, and the probability of getting that result, and if I do it again, I'm going to get a different measurement, and after a great number of measurements that we saw illustrated on that video, it's going to build up exactly the probability distribution. So we like to call that interpretation the shut up and calculate interpretation, meaning all this stuff about many worlds, you know, it doesn't matter. In the end, I know how to do the calculation, Max knows how to do the calculation, we get the same answer, and when we go into the lab, we get the same results. And whether...
Right. And again, it's completely dependent on the circumstance, so they can't use the same... formula, so to speak, to do Newton's glass that they use for the interference pattern in the two-slit, or you know, a heat index, you know, the photoelectric effect, some other thing. They can't use the same formula. They always are putting different formulations of variables, and so they just given that a symbol and said we're going to call that one thing, but it's not one thing. It's a whole different bunch of formalizations, and it just has to do with analyzing statistics. Analyzing the output statistics does not tell you anything about cause. And frankly, cause is what science is supposed to be trying to figure out.
I accept Max's result or whether I accept the shut up and calculate answer, I get the same answer. Now
let me ask Dave Albert, because I sense you're treading on Dave Albert's toes a little bit. How do you feel about that? That if you just shut up and calculate, are you missing anything? Are you missing any of the fun in life?
Yeah, yeah. It seems to me you're missing much of it. Probably all of us initially got interested in science because we wanted to know what was going on. So there ought to be a resistance. It's proper for there to be a resistance to someone who tells you that there are certain sorts of questions you're just not supposed to ask. Nobody is born and opens their eyes with an intrinsic interest in how a particular experiment is going to come out or how to do a particular kind of calculation. The kind of interest we come to the world with, I think, is an interest in what's going on. And if
Yes, it really just is cause and effect, and you want to know the causes to the effects. That's it. How do you catch a cold? Oh, you get a virus in your nose, and then it spreads in your nose, and then it transfers to your lungs, and blah, 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 blah. Yeah.
it's really the case that there are certain questions about what's going on that it turns out to be inappropriate to ask, it seems to me right to regard that as an enormous disappointment of the whole scientific project. And so in this respect,
So he's basically, without being rude, he's basically saying, your shit is science, okay? This shut up and calculate shit, that's retarded. Okay, what? Because Richard Feynman gave up and decided I can't think about it no more because I can't figure it out. Therefore, we should all just not think about it anymore and not figure it out. You know, because if Richard can't do it, none of us can do it. I mean, it is really just, you know. So instead of calling him an asshole, he instead does this little bullshit. Because they have to make it look like their physics is secure. When clearly, this is a huge divide in processing.
very broad brush respect, I guess I'm closer to Max. I'm interested in trying to figure out what's going on, in trying to be able to tell us.
Well, you know what? You can figure it out really easy. You just analyze their evidence. You just go back to the two-slit experiment and you say, does Young's drawing create the right pattern? No, it doesn't. Does two wave functions interfering with each other create the right pattern? No, it doesn't. So, well, you're done with that, right? I mean, that doesn't work, so find a better answer.
Story of why it is that these experiments come out as they do, rather than just having a method which might as well be close your eyes and say abracadabra or something like that for calculating how they come out. I think that the particular story that Max is enthusiastic about is a story that seems to me to have.
I mean, he's a professional. Shouldn't be doing that umming stuff. But anyway, now he's got me doing it. Okay, broke my trains of thought. Anyway, what was I going to say? Yeah, it's just kind of funny that he's saying, well, I'm more like Max, but I don't think this guy believes in multiverses.
A lot of problems. The problem isn't that it's wacky. It's pretty clear that the world is wacky. I think there's a useful distinction to be made here.
See, I don't think it's pretty clear, right? Is it pretty clear that the world is wacky? I'm saying it's pretty clear that everything looks like a robot. Cats are cats, and dogs are dogs, and minkies are minkies, and whatever. Ducks fly, and, you know, all that kind of. Sharks eat ducks now and then. You know, pond sharks. Yeah. Fuck this. There's nothing. There's no indication of a huge amount of wacky. It all looks pretty mundanely stupid. You know, that we go through these same stupid processes. We get hit by the environment. The environment's rude to you, and then you get a complex, and you get a whole psychological issue, and then somebody treats you badly, and you get angry, and you key their car, you do some other bullshit, blah, 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 blah. I mean, it doesn't seem that wacky. This is wacky. That smart people indulge in these kinds of bizarre conversations about, you know, fairy tales, that, and pageants, and doing pantomime.
It's pretty clear that the subatomic world is strange.
No, it's not pretty clear. It's pretty clear that it has all these conservation rules. It's got really simple, like R-squared rule, you know, like distance, things get 4 times smaller, you know, with half the distance. I mean, all those kind of, you know, it's nothing. Once you understand the mechanisms of what the straight lines are doing, it's all straight lines, assholes. It's pretty, it's not very complicated. Straight line force answers all the questions.
Way or another, no matter how you cut it. The important distinction is whether it's merely strange or whether it's strange in such a way as to make it literally unintelligible. Whether the world is stranger than we know or stranger than we can know. Okay.
Well, that's even, you know, cutting a, you know, piece of dog do in half or something. I mean, you shouldn't be playing with the dog do in the first place. Notions about strangeness, your first reaction should be, if it seems strange, it's because I'm ignorant, right? It seems strange that the magician can pull a pigeon out of thin air. or the rabbit falls out of the hat. It seems strange. But I know it's not strange. I'm just ignorant of how it happened. But rabbits didn't poof, and pigeons don't poof. So I know that. I know there's an answer. Why would I sit around saying, wow, gee, that's strange, and it must stay strange?
The worry about the many worlds interpretation, I think, maybe I can be a little bit more concrete about this. The reason we have for believing in quantum mechanics in the first place, the hard evidence that we have.
All right, there's no definition of this thing called quantum mechanics, so it's kind of a useless term, right? Because we don't know whether quantum mechanics means Copenhagen or many worlds. We don't know whether it means entanglement is real or entanglement is left and right gloves. We don't know any of this, so why even say quantum mechanics anymore?
Something in the neighborhood of quantum mechanics is true has to do with observing statistics of repeated measurements on similar systems, okay? The kinds of experiments that Brian was talking about before. The worry about the many worlds interpretation is that it's not going to be able to account, since it's an interpretation that says everything happens for sure. It looks like it's going to be at a loss to account for why we observe these particular frequencies as opposed to those particular frequencies, why we observe these particular statistics of outcomes of measurements as opposed to those particular statistics.
Well, it guarantees that you're saying that the variation is caused by woo, because yes, you're not pursuing the cause for why something got cloned, so to speak, how it could possibly have been in two different places at once. So yes, it establishes some notion that something has clones. And there's no evidence for this clone thing.
Of outcomes of measurements when we repeat a measurement a bunch of times. Because the many worlds interpretation says all of those statistics are going to occur for sure. Okay. Here's a slightly different way to put the worry. Quantum mechanics has these probabilities at the bottom of it, which we've been talking about. And the reasons we have for thinking quantum mechanics is true are precisely that the kinds of statistics we observe when we do these experiments are the kinds of statistics that these probabilities say are the statistics we ought to expect.
Let me pick you up on that.
I mean, you said it a different way, it didn't make any sense at all. So again, the statistics are a byproduct of usually the variables, and so that's all you say. You add more variables, you'll make your statistical byproduct in terms of cause and effect a lot harder to trace. So the more roads there are to roam, it gets harder to predict which road they took.
Let me ask Brian, too, because it's a very interesting question. Those of us on the outside of this mysterious realm that you people study so assiduously, we hear about how it works on chance, and it sounds a little fuzzy to us. And yet,
no, all of it's fuzzy because they're saying they're saying the causes that do exist, the physical ones, we can't see, and there's non-physical causes. So we can't even see the physical causes, and they'll concede it. And yet they're claiming the existence of non-physical causes that, of course, you can't see. So that's how vague it is in terms of why would you even invent those non-physical ones? I mean, you don't need them because you already can't see the physical ones.
Brian, isn't there an accuracy in quantum mechanics that's amazing?
Yeah, I mean, quantum mechanics is the most accurate theory that has ever been written down.
There you go. I mean, just absolute nonsense. I mean, it's like saying, again, it's like me watching something happen and then predicting results, like watching cows eat grass, and then tomorrow I say, I predict the cow will eat grass. I mean, there's no predictive power that they don't already put into the equation by observation. So the whole thing means absolutely nothing. This most powerful math in the history of mankind crap. It's just a crap.
By a long shot. But what it's accurate about is unfamiliar, right?
Okay, so what it's accurate about. It isn't accurate about anything. So again, this idea that it did some actual work, it didn't do anything. You had to put the soda in the soda machine before the soda machine produces the soda. There's no magic to your math. Your math doesn't do anything but tell you what you already know.
So it used to be in the time of Newton that if you want to know where a baseball will land, you use the laws that Newton wrote down and they predict exactly where the ball will land. So that's the kind of data that you use to support Newton's view of the world.
Yes, and it works as long as you know everything you need to know about wind and all these other stuff, all these variables. So as you know all the variables, the mechanism is known. The cause is known. The velocity and momentum is known. So there's nothing to confuse you. And you're just saying that I have special math that tells me unknowns. No, you don't. Because you have to know the unknown exists. You have to know the baseball doesn't land where it's supposed to, and it's not landing where it's supposed to for a reason. And you know that. You just don't know what the reason is. You know there is one, but you haven't identified it. You've just identified its effect. And you did that by seeing it.
Quantum theory says that's just wrong-headed. Quantum theory says what you should be predicting are the likelihoods, the probabilities of the ball landing here or here or here. And if the math says that
there is no probabilities, that's the whole point. In Newton's math and Newton's structure, the prediction is guaranteed because you know the variables. You're just saying, well, let's take away your knowledge of the variables. So now you don't know its momentum, and now you don't know this, and you don't know that. Well, then Newton can't predict it either. So it's exactly the same circumstance. There's nothing that's changed. If I take away from Newton knowledge of the mass of the baseball, he can't predict where it's going to go.
the ball will land 30% chance here, 30% chance here, and 40% chance here, then do the experiment 100 times. And if it turns out that 30 times more or less it lands there, 30 times more or less it lands here, and 40 times more or less it lands there, then you're confirming the probabilistic predictions of the theory.
No, you're just confirming that there's some variable that changed between each one of those times you launched the baseball, right? So it's just where it hit it on the bat. Some bad baseballs go over the fence. Some baseballs go straight up. Some baseballs go backwards. You know. Yeah, I know there's a reason. It's because the bat isn't some constant. The bat variably hits the ball in variable different ways at their variably different angles. And so you have a variable result. Where have they demonstrated there's any reason to think this isn't about how the bat moved and how the baseball moved, and when the two of them hit each other, how they hit each other, and that everything is in that fact? There is no woo. There's no quantum gods that say home run.
Now, this example with a little ball is one particular one that I just cooked up in order to explain the basic idea. But when it comes to particles like electrons, you can do a quantum mechanical calculation of a property of the electron. Its magnetic properties. The details don't matter at all.
Yeah, right. They don't matter at all. It's right that we gave it a bunch of features. There's no reason to think it has magnetic moment, some sort of magnetic thing. So the electron that is this simple negative charge, that's all it seems to be, has some other feature. It has special antenna, magnetic antennas on it, and it points them every now and then.
The calculations are extraordinarily difficult. It took a group of physicists more than 30 years to do the calculations, but by the end of the calculation, they had a number that emerged from quantum mechanics, 2 point whatever, 10 decimal places long. They go out and they measure.
Right, and it doesn't have anything to do, the two things don't have anything to do with each other, right? They're measuring what's a real effect, which is atoms change when you shoot electricity through them, and they create a magnetic difference. And it doesn't have anything to do with electrons specifically. I mean, they're not the only player in the game of the effect. And so now they're just saying that the electrons caused it. Well, the cause is clearly electrons by themselves won't cause it, so that doesn't work. You know, it's just so bad.
Measure that particular magnetic property of the electron, and digit by digit by digit, 10 decimal places long, it agrees.
Right. Well, the two analyses have nothing to do with each other except the fact that, yes, you're sitting there saying what's you've already assumed the electron is more than it is when you start to calculate what the magnetic moment is. This thing is not just an electron property, but you decided in the math you're going to say it is. And that's the only difference here. You could have said this is the magnetic effect and you're trying to predict it or calculate it. But clearly it's a real thing. It's not some fake thing. And so again, their formula didn't predict the cause of it. It's just predicting the fact that it has to have this much effect because we know how much things move. We've measured them moving, so we know if we can figure out how many electrons are in something, we can figure out how much each electron is responsible for the outcome, sort of thing, right? If there's 50 people in the room and a certain thing happens, then we can blame it on the 50 whole people. Or we could blame it on one person. it really doesn't matter, because all we're doing is saying there's a certain effect, and the effect is, something we can measure.
With the prediction. That tells you that you're onto something.
Really doesn't.
It's unusual, but you're onto something.
Okay, so given that incredible degree of accuracy, why did so many...
It's like you could have a bunch of people in a room and they're all different weights, and you take their collective weight, so there's a certain weight, and then you figure out what the average. So if I take 50 and divide it into that total weight, I'll get an average weight, and I'll just pretend that all the electrons are the same weight. And then I'll say I have the most predictive theory in the history of mankind. When, no, all you did was take away all the character of the people and say they're all the same weight. You don't know that. You've just divided each one's responsibility for the total scale bending and decided to apportion it evenly. But you have no, if you look at the room, you could see that some people are bigger than other people, and that the total weight wasn't evenly proportional.
Many great physicists have problems with this, especially in the beginning. Let me ask you.
Yeah, well, first of all, let me say that I want to amplify what Brian said about that kind of accuracy. There's those two sides of quantum mechanics. On the one hand, you predict only probabilities for the outcome of a result, but on the other hand, it's incredibly powerful in predicting the exact value of certain kinds of properties. And
So again, it doesn't do any of this stuff. It's garbage in, garbage out, good numbers in, good numbers out. That's all there is. Any statistical analysis is dependent on you understanding the variables, right? So I'm just saying, if you get the variables correct and you've isolated all of them, then you can get a very precise number. But if you're missing something, then you won't get as precise a number. If you're vague about whether there's 49 or 50 people in the room, well, yeah, then your number's not going to be too exact.
particularly glad you brought that one up, because I actually had something to do with that measurement. And it's an extremely satisfying thing when you do this, and it comes out the way the theory predicts. But even more satisfying is if something comes out different from the way the theory predicts, because it's so much more exciting.
And so this isn't science, right? Oh, it's so much more exciting not to understand very well. No, that's not exciting.
Because you learn something new.
La 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 la. You can do that doing anything. You can stick your little head up your ass and you'll learn something new.
All you ever do is have a theory, and you always make your measurements, and you find out that the measurements agree with what the theory predicts. You haven't learned anything new. Now,
oh, gee, I mean, it's just so special.
In fact, the thing that Brian was talking about, the strength of the magnetic field of an electron, early on in the history of quantum mechanics, people thought they knew how to predict it. And they did, and until people started making really careful measurements, they thought they had it right. When they started making measurements a little bit more carefully, they found out, ooh, it's not coming out quite right, and they learned...
Yes, because they had missing variables, period. Nothing that complicated. They hadn't accounted for all the energy. La 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 la.
Something new about the theory as a result. So now, Dave is talking about the excitement of...
So all this talk, right, about all this stuff, they can measure about electrons, magic, moments, all this kind of crap, and they still haven't figured out that their math doesn't predict the two-slit pattern. Not even close. The two-wave theory of two slits doesn't even come close.
Of understanding reality. Well, there's another kind of excitement in learning something new. And even when that learning something new is a new mathematical theory, that's incredibly exciting.
Yeah, especially when you're wrong. Especially when you have no evidence.
And that's what happened when this new idea that, well, we call it quantum electrodynamics, that was added on to quantum mechanics, that allowed you to do this incredibly accurate calculation that Brian talked about. Now, the darn thing
That's bullshit.
is that it works so well that...
Right, so we're back to like Feynman's math, right? I mean, they're just, all they're doing is doing this simple idea of this is statistical analysis, and they think they found some sort of Rosetta Stone because they figured out that, yeah, it's a probability, so it's like a clock. It just goes around and around and around and around. And if you know how much time it has to go around, it goes around at a consistent speed, then you can figure out if it starts at 2 o'clock and you know exactly how much time it takes to happen, you can figure out that it's going to be 6 o'clock when it stops. And then you do a square, you just take you do the Pythagorean thing to figure out it's a percentage. of that outcome being, how often that outcome can be expected. And just, squaring the amplitude, so to speak. And so it's not really complicated math. It's probability analysis. This is statistics. This is nothing about cause and effect. This is just analyzing statistics.
Every time we make a measurement, we get just what the theory predicts. It's kind of disappointing because, the really exciting.
I had no idea quantum mechanics was so boring. One prediction afterwards.
So again, they just keep talking about it as if it works, and they can't get it to work with the simplest friggin' experiment known to their physics. The stupid double slit. Their math doesn't work.
But to get back to your real question,
Yeah.
why
Why did people
so
resist it so much? Why such smart people?
Well, Einstein, perhaps one of the smartest people that ever lived, couldn't
Well, whatever.
buy quantum mechanics. He just didn't like it. He said famously that I can't believe that God plays a dice with the universe, and that's why we had the dice dance. And I think
Well, he not only was against dice, he was in favor of dancers.
You had a point.
and I'm sure he was. Well, and I think that it's just what you were alluding to at the beginning. It flies in the face of everything that we understand from our ordinary experience. And
No, it flies in the face of the scientific method to jump to the extraordinary explanation when you haven't fully tested the ordinary explanations. That's what loop-de-doo conspiracy theories people do. They are the ones who jump to the bizarre conclusion because they have a motive of some kind. So you're just doing what the religious people want to do, which is pervert the facts to make them fit their silly little narrative. And that's all this shit is. It's a religion.
ordinary experience, things aren't in two places at the same time. In quantum mechanics, they are. In our ordinary
And they really don't have any evidence at all.
experience, something is here or it's there. Cats are either alive or they're dead. They're not both at the same time. And now, in Max's world, the cat's alive in this world, the cat's dead in the other world. And there's no problem for Max. But for Niels Bohr and Einstein, there was a big problem because they couldn't.
Yeah, there's a big problem inventing universes to get yourself out of a quandary. That's a big problem. So you think your client's innocent, and the only way you can make up a story that he's innocent is you have to blame it on the invisible man, and you go ahead and do that. I mean, that's just silly.
And couldn't buy this idea that a cat could be both alive and dead at the same time until we looked at it. But the amazing thing is that every prediction that this weird theory makes about the way the world works has been verified.
So they just say that shit. It's just nonsense. Every prediction. And again, the predictions are not predictions. They're really not predictions. They already know going in what the outcome is. They didn't predict it. They detailed everything about the thing and then predicted. Again, if I'm told everything there is to know about something, it's not going to be a prediction when I tell you what the thing is. I mean, if we're doing What's My Line and the guy has his, his cop suit on, okay, and he's swinging his club, and, this isn't going to be a tough call.
And it is just the way the world works. In other words, Einstein was absolutely right to say that quantum mechanics is just horribly weird, impossibly weird. And it turns out that that's the way the world is.
All right, and it turns out with all the big pile of evidence we've compiled, when their simplest evidence, when the origin evidence can be demonstrated to be a pile of crap. There was no reason to go down this silly road, and there isn't more evidence at the end of the silly road.
No,
But it's not.
I think
the
there's
data
a
wants it to be otherwise.
I think there's a distinction that's worth making here. If I can jump in, it's one thing to be surprised that the world turns out to be this way or that way. Somebody says the world turns out to be this way. You say that's very odd. That's unlike my everyday macroscopic experience. That's a surprise to me. So on and so forth. It seems to me the right answer to that is to say, too bad for you. Nature wasn't designed to make you comfortable. Nature wasn't designed to be familiar, so on and so forth.
Oh, yeah, well, whatever. Yeah, but everything we've discovered is that the causes, the mechanisms get simpler going down, not more complicated going down. The little tiny things don't have brains, and they don't have this, and they don't have that. I mean, there's no reason to think the microbes have, AI. They have supercomputers. It's silly to think that. Because everything that we see in this universe sort of dictates that the complex features have to be derived out of complexity. And the complexity isn't in the elements, it's in the arrangement of the elements. The dots make the picture. There aren't pictures in the dots. Alright, maybe this is enough, and we'll do the entangle one last for another video. This will be just that subject of the silly entanglement and the silly stories they tell. Again, the perversion of history. So here they have Schrodinger arguing for alive and dead cats when he was arguing for exactly the opposite. You know, just screw accuracy all over the place. And they talk about how they have the most accurate theory in the history of mankind. They can't even tell a simple historical fact about something that happened, 75 years ago. They can't tell that story accurately. And you trust these people. Shit.